each other. Now we'll focus on confounding. So confounding, if you look at the dictionary meaning, confounding means confusing. And what we are going to look at is the concept and different ways of understanding confounding. Then what are the ways of identifying potential confounders for your research question? Then why should we be concerned about confounders? What is the impact of these confounders on our results and interpretation? What are different ways? I'm sure many of you already know about ways of controlling confounders. And then some examples and how to interpret your findings when you are handling your confounders. So beginning with the conceptual understanding. So there are different ways in which you can think of confounders or confounding. One is mixing of effects. That is, when the effects of two exposures are not considered separately, you are looking at one particular exposure and outcome, and you know that there are other exposures associated with your exposure of interest which could affect the outcome. And that kind of study design leads to mixing of effects. So you don't know how much of this association is truly because of your exposure. That is one way of thinking of confounding. Another way of thinking of confounding could be if you want to study, for example, an intervention, you have an intervention group. Actually, to study the effect of the intervention, you would have to have the same group at the same time without any intervention. Only then you will truly get to know the effect of the intervention. But that is impossible. What it means, at the same moment, you are giving the intervention as well as not giving the intervention and comparing the two. So to face this problem, what is the alternative? You have another, say another sample, which you feel is similar to your intervention sample or population, and you want to compare the two. But if the two are not distributed similarly for important variables, then naturally you won't get to the truth, and that will lead to confounding. That is another way of thinking about confounding. And these two could be little difficult to understand. Then you have these two, the last two, which we are going to really look upon in great detail. That is the classical definition, in which we are looking at alternative explanations for the association, and then the collapsibility, which was mentioned in terms of stratification, and jumping or checking for effect modification, and then confounding comes here. So we will look at these two in more detail. The first two help us to understand confounding, and whenever you have your research questions and you are thinking about your exposure outcome, you also have to think of a series of other variables which could be potential confounders. And this is a motivation for considering those variables, because without looking at those variables, you will never get to the correct estimates. So let us look at these two definitions or concepts which are there, the last two. So the confounding, now what is this? It is a situation where an association between an exposure and outcome is entirely or partially due to another exposure. Now this I have a couple of times in my department, I have shown this picture. That is, you see two people together, you feel that, okay, they are friends, but actually these two are friends and they are hanging around together, and therefore you are seeing these two together. So your interpretation here, which is there, is confounded by this person. So this is the classical definition of confounding. So there are three criteria which Anjana was mentioning, which are there, which this example should help you remember. One is that the confounder, the potential confounders of interest, they are independent risk factors for the outcome. So the confounder is an independent risk factor. Then this variable is associated with the exposure. It may not be a risk factor or not causally associated with the exposure, but it is associated with the exposure. And it is not on the causal pathway. That is, it is not a mediator for the association between exposure and outcome. Any variable which meets these three criteria, you will call that as a confounder. I repeat, if there is a variable which is a known risk factor for the outcome, it is also associated with the exposure, but not on the causal pathway between the exposure outcome, that becomes your confounder. So let's look at an example. This is a very simple example, again, just for us to understand and to remember. You are interested in the association of alcohol and lung cancer, but you know that smoking is an independent risk factor for lung cancer. You have evidence. You also have studies which are reporting that those who drink alcohol are more likely to smoke. So there is no causal association here, but they are correlated or associated with each other. There is a positive association between the two, and smoking is nowhere in the causal pathway between alcohol and lung cancer. So smoking meets the criteria for confounder, and you have to consider smoking as a potential confounder in your study. So you need to identify all such potential confounders, and you need to adjust them in your study, either in your design phase or in your analysis phase. So this classical definition is a very easy one for us to understand as well as to implement in our studies. Now, how do you identify potential confounders using this definition? A very interesting technique is the directed acyclic graphs, or the DAGs. So for all of your research questions, you should try and draw such graphs where you have the exposure, you have the outcome, and you have to then write down all the potential variables which you feel are risk factors for the outcome and may be associated with the exposure. A easy way to do this would be to jot down all the risk factors. So all the risk factors or factors you know are associated with TB treatment outcome. So what you would do is you would search literature, do a thorough review of literature, and find out all the variables which you know have an effect on the TB treatment outcome. And then also look at literature and also use your common sense and think whether any of these other variables could be associated with diabetes mellitus. Then you also think whether any of now these variables which you feel meet these two criteria are on the causal pathway. If yes, cross them out, and the remaining ones which remain with you are the potential confounders which you should consider for your study. I will stop here and ask you all if you have any questions.
Ma'am, confounders would not be on the causal pathway, whereas effect modifiers might be. So, if we are making these DAGs, there at that point, how do we differentiate between?
No, effect modifiers will also not be on the causal pathway. It is the mediators which will be on the causal pathway, right?
Okay.
Yeah. And your question is then how to?
We are making this DAGs.
Yeah.
Where how can we anticipate?
Yeah.
Which one of them would be
Yeah.
falling?
So the DAGs actually help you to find out and to differentiate between effect modifiers, mediators, and the confounders. So you have to keep reading. Now you have enlisted, say, 10 different variables, right? And you have to then look at the association of these variables with the exposure outcome. And if there is any report suggesting that one of the variables could be a mediator, could lie on the causal pathway, then in your DAG, it comes here as a mediator, and you have to then rule it out as a confounder. You're getting me, Dr. Neha?
Yes, ma'am. Yes, ma'am.
Yeah. So in fact, the DAGs help you to finalize your potential, not finalize, but at least to identify your potential confounders.
Okay, ma'am.
So I'll show you another example. So this is a DAG which we had done for one of our study, where we were interested in the association between diabetes mellitus and a TB treatment outcome. Now, instead of severity of disease, I would have taken the, say, the control of hyperglycemia, or the glycemic status, or the effect of the drugs, or something like that. So all of the others we could find out as a potential confounder, but diabetes mellitus, and it could be, say, some medication. If I here I have taken the medication, I could consider it as a mediator, or diabetes mellitus leading to some change which could affect TB treatment outcome, say drug interaction or something like that. So what happens, each of this, now it is up to me to rationalize and to think whether to put a particular variable as a confounder, as an effect modifier, or as a mediator, and to rationalize and to write in my methodology. So confounders, if you say all these are confounders and the literature is clearly stating their associations, then you will say, okay, this is the reason why I'm thinking of them as a confounder. But if you are mentioning them as a potential effect modifier, or as a mediator, you will require a reference to show that how or where is the evidence to say that this particular variable could be on the causal pathway between your exposure and the outcome. So your DAG visualization actually helps you to think through and to decide. So for many of these, you could think of them as effect modifiers, and then you could check whether they are effect modifiers or not. So it is up to the investigator to decide how they are going to handle their variables.
Okay, ma'am.
So the DAGs actually help you in that direction. The next question is, okay, you are interested in potential confounders. Then what are the ways of identifying potential confounders? So usually you are very clear about your exposure and your outcome. So what are the other variables you should consider in your study? There are two ways to do this. One is knowledge-based approach, that is based on the literature, existing literature which you should study. And what are the previous studies saying? Focus, or first identify the potential risk factors for the outcome, and then follow the steps which I have told you. Another way is to find out about other biologically plausible risk factors for the disease. So for some, say, newer outcomes or newer diseases, maybe there are not many studies. So you may have to think on your own, depending upon the disease, what could be other possible risk factors, and then come up with potential confounders. The other way is a data-driven approach. It means that I have collected my data. Within my data, I will check whether I need to consider any of the variables as potential confounders. So I will be talking about this in detail later on. That is, within your data, are there ways in which you can say that I have 15 variables, but I am going to check out and see which of these I want to adjust to get a adjusted estimate of the association between, or the effect of exposure on outcome. So how to do that, we will see in the upcoming slides. Now, another way of considering or understanding confounding is collapsibility. Now, here Dr. Anudeep mentioned about stratification. So that concept comes here. So collapsibility means what? You do a stratified analysis. So first step is to calculate your crude estimate between your exposure and the outcome. And then you have a confounder, right? A confounder, you find out the strata for the confounder. Two, supposing there are two strata for the confounder, yes and a no. So your alcohol, crude estimate between alcohol and lung cancer. Smoking was your confounder. So smokers and non-smokers could be the two strata. Now you calculate the estimate, or the odds ratio separately for the two strata. So you have stratum specific estimate for the smokers, and you have the estimate for the non-smokers. Now, as Anjana mentioned, your first step actually is to see whether they are similar or close to each other, these two estimates. If they are similar to each other, it means that there is no effect modification. You calculate what is known as a weighted average of the estimate. So you combine these two together, you take a weighted average and you compare this weighted average with your crude estimate. So this is the second step. And if these two values are equal, then you would say there is no confounding. But if your stratum specific estimates which are similar to each other and their weighted average is different from the crude estimate, it means your weighted average, you cannot collapse it. These two stratum specific estimates cannot collapse or connect, are not similar to your, when brought together to your crude estimate. Then you say that there is confounding. Are you getting me here?
Ma'am, could you please repeat?
Yeah. See, collapsibility means what? You have two variables, alcohol consumption and lung cancer. You calculate the crude estimate, the odds ratio. I'm just taking the example of the odds ratio. It can be true for other estimates also. So you take a crude, calculate the, or come up with a crude estimate. The next step is to calculate the odds ratio for the subgroups of your confounder. So here smoking is a confounder. So I have two subgroups or two strata, smokers and non-smokers. So for the smokers, I calculate an odds ratio for the effect of alcohol consumption on lung cancer. And I do the same thing for the non-smokers. So I have two odds ratio for these two strata of the confounders. Now, if these two are similar to each other, the next step is to calculate a weighted average of the two. So I get a weighted average of the estimate and I compare this weighted average with the crude estimate. If they are similar to each other, then there is no confounding, that is, there is collapsibility. If the two are different from each other, there is no collapsibility, they are not similar to each other, so I say there is confounding. I will be discussing this in detail in the analysis. So those who have understood, well and good. If there is a difficulty in understanding this concept, we are going to come back to stratification and stratified analysis, and we look at this concept again in detail. So just hold on. So I move forward. So remember that when you are doing your analysis, there are different options for considering confounding. I'm going to come back to this again later on, but just how, what are the ways in which you can decide upon which factors to consider as confounders is what is written here, but this will increase, I think, the confusion. So I'll come back to this later on. Now, what are the implications of these confounders? Why should we consider or be worried about the confounders in our study? So, remember that confounding can cause an apparent association when there is no association, or there is an association and you say there is no association. So both ways you are committing an error in your results and your findings. So it could be a gross mistake you are making if you don't handle confounding in your study. Now, after you find that in the crude association that you find a significant effect and you adjust for confounding, then you will know that, okay, only part of this effect is because of the exposure, rest of it is a confounding effect. So without adjusting for confounding, you will not be able to differentiate or identify the partial effect of the exposure on the outcome. You will attribute the entire effect to the exposure, which is a mistake. Then you could overestimate the true association. Okay, even after confounding, there will be an association, but when you adjust for the confounding, you know that the association is not as strong as you thought, right? It means your confounder has led to an overestimation of the true association, which is again a mistake you are making, or it can lead to an underestimation of the association. Now, if your confounder increases or strengthens the association, you call it as a positive confounder. If your confounder reduces the strength of association, you call it as a negative confounder. Again, I'm going to come back to this concept later on. These two things you need not think too much, but remember that you can make gross errors in your estimates if you do not control confounding, especially when you are wanting to study a specific association between one exposure and outcome. So here is an example. So the exposure is heavy coffee consumption and cardiovascular disease, risk of cardiovascular disease. Now, supposing you find an association between coffee consumption and cardiovascular risk of cardiovascular disease, right? But heavy workload, long working hours, or stress, these could be potential confounders. Do you agree with me? If you think of the triad, do you agree with me?
Yes, ma'am.
Right? So you
Yes,
are
ma'am.
interested in coffee consumption, you are interested in the cardiovascular disease, but you know that, say, long working hours can increase this risk, lead to stress can lead to this can lead to this, and this will not be in the causal pathway. Now, what will happen if I don't look at these confounders, right? What will I come up with a study and I report that increased coffee consumption leads to increased risk of cardiovascular disease? What will be my recommendation in my
Uh,
study? Yes, Dr. Anudeep.
Ma'am, in this case, should we look like coffee consumption is associated with other factors like smoking and all?
Yes, there
People,
would be others. This is just for an example. I have just taken as an example. There could be n number of confounders, right? So there could be smoking. What you are saying is right. There could be smoking, and there could be many other factors. But what I will recommend is reduce coffee consumption to reduce the risk of cardiovascular diseases, right? But it
okay.
could be that the risk of cardiovascular diseases is not because of coffee consumption, but these other confounders. So reduction in coffee consumption is not going to reduce the risk of cardiovascular disease. You're getting me? So the recommendation which you are making could be thoroughly wrong if you do not consider confounders. Again, a simple example, which again, the common example, say of alcohol and lung cancer. I find an association between alcohol and lung cancer and I report it in my study. I do not consider confounding. So what will be my recommendation if I want to reduce the risk of lung cancer, my recommendation is reduce alcohol consumption. But will reduction in alcohol consumption reduce lung cancer? Obviously not, because smoking is a confounder. I should have adjusted for smoking and I would have found that probably it's a weak association or no association, right? So my recommendation itself, I am making a gross mistake by not considering and adjusting for the confounders. Why I'm giving these examples is just to highlight the fact that if you are looking at associations, it is utterly important that you look at confounders and adjust for confounding so that you come to the truth and give correct recommendations. Are you all with me?
Ma'am,
Yes.
Yes,
Ma'am.
ma'am.
so for example, in this case,
Hmm.
coffee consumption and cardiovascular disease. So this
Hmm.
was my initial assumption, and
Hmm.
when I did the straight up specific estimate, I realized that okay, this long working hours or stress is has a stronger association that my than my initial outcome that exposure that I had assumed. So
Hmm.
that means that my hypothesis itself was not scientifically sound, or perhaps it was wrong in the first place. So then what happened
No,
from
yeah,
that?
no, yeah. See, we have to do the thorough review of literature to come up with a research question.
Hmm.
And it is absolutely okay that your crude estimate, you find that there is a strong association between coffee consumption and cardiovascular disease risk, but your adjusted effect, there is no effect. So you
Hmm.
report it as such and you say that
Hmm.
there was a strong confounding by these other factors and there is no effect of the exposure on the outcome. So you report your findings. There is nothing wrong out here. You have a particular hypothesis which you are testing, and you are adjusting for the confounders, and ultimately you see that there is no effect of the exposure on the outcome. So you report your null effect. It is not wrong.
Okay.
Yeah. So we have to remember that it is the reporting significant effects is not the right thing, and reporting the null effect is not the wrong thing. Both are right. Even if you have a null effect, you have to show that this showed an effect, a positive effect, but when I adjusted for these all confounders, I lost the effect. So this is not a risk factor. This is absolutely okay. That was a good question, actually, Dr. Neha. So the steps are, you identify your potential confounders. I told you there are two methods, that is your knowledge based and your based on just your data. You want to identify the confounders. This database is of course something which happens in the analysis, and the knowledge base, which is basically your DAGs. This is right in your planning. When you are planning your study and your methodology, you are deciding upon your confounders. Now, once you decide, you have a list of potential confounders along with your exposure outcome, you need to collect data on the potential confounders. Then you have to decide whether you are going to handle the confounders in your design phase or in your analysis phase. And then you interpret your results carefully based upon what you have done with your confounders. And then also mention all of this in your results, whatever you have found in your results, in your discussion. So in your methodology, confounders have to be explicitly mentioned, and how you have handled them, identified them, all that has to be written in your methodology section.